Okay, let's go ahead and calculate skewness and kurtosis for some of our data here. It's actually pretty straightforward in Excel. Let's start with, I don't know, children. Let's do that one. So let's come over here where we have some room, and skewness. Okay, pretty straightforward formula, equals SKW. There we go. Let's go over here and grab our array of numbers for children. Control Shift or Command Shift down. Enter. 0.392. Okay, let's do kurtosis. Equals Kurt, there it is. Over here to children. There we go. I didn't want to do that. There we go. That's what I want to do. Let's do income. Now, obviously, because these are numeric formulas, it's not something we calculate on categorical data or dichotomous or binary data. Let's go ahead and do income next. The nice thing is, because I have a table put in, I don't have to use the cell references. I can actually do this and change children to income. Whoops, I gotta spell it right. There we go, children to income. And I can do that for each of my variables. So the question is, what do these numbers actually mean? Let's pull up our graphs again, our definitions of these. Here we go. So, skewness. It's going to be 0 if it's just right. If it's going to be greater than 0 if it's skewed, well, they call it, I'm just going to call it this direction. If the lump is on the left, and it's going to be negative if the lump is on the right. So let's take a look at our numbers here. Skewness, children's 0.039, because it's positive, it means it's slightly skewed this direction, and income skewed a little bit more that direction because the number's bigger. Kurtosis, negative means that it's flatter than it should be. Positive means it's pointier, spikier than it should be. Well, how much is too much? That's the real question. So there's lots of different rules of thumb for this. The one that I'm going to give you comes from this source right. Oh, there we go. This source right here, Trokin. So this is a book I use in my PhD program. Great book. His rule or her rule or their rule is plus or minus 2. That didn't work. Not equals. There we go. For both of these. So numbers above 2 and below minus 2 are too non-normal to be used. So what can we do if our variables do end up too non-normal? We actually do have some options. We can do some logarithmic transformations to the data to try and get those numbers into normal ranges. So let's test some others here and see if we can find, let's try age and see if we can find any problems with age. So let's change this to age. No, both of those are good too. The problem is we have a data set that's already been super clean and has all this taken care of. But let's do, let's go ahead and try it anyway, and let me show you how it affects things when we make some changes. Let's take age, which is pretty good. Let's use children instead, because that one's got a -1 there. Here on children, let's do a natural log transformation and change this to children ln. So let's just change this. Oh, this isn't going to work. I can't do the natural log because natural log of 0 is undefined. Let's not do this with children. Let's do this with income. And we'll call it income ln. So let's just say this is going to equal the natural log of this field. And let's change now on income here. Here's our skewness one. Let's change this to income ln. Now before it was 0.75, right? Now it's -0.74. So it's slightly better, not a whole lot better. This doesn't always fix your problem, but at least it can help at times. So let's take a look here at kurtosis. See if that helps things at all. Let's see, what was it before? It was 0.513. That one helped a lot. 0.15. So there are a variety of transformations. I won't go into all of them here, but just know that skewness and kurtosis is something we need to check for. And if it does violate this rule of thumb of being too big or too small here, then that limits our ability to interpret the data, and there's a possibility that we can overfit the data, is a term we use, where our population is not truly representative of the overall population. And so when we do a regression based on this data, our weights could be incorrect, or we call it overfitted. They're based on our population, which is not truly representative. So that's how we detect and handle skewness and kurtosis.